Tactical grid. Today we're gonna add a new view mode to be able to display a tactical grid in the game. Because even though it's great to have awesome environments in the game, sometimes we just want to be able to focus on what's happening and evaluate all the possibilities. So let's get to it. So how are we going to do that? Well, first, we're not going to change the current grid because the current grid is great, it's working, it gives us the possibility to interact with everything, and it works perfectly. So we're not gonna trash that, we're gonna keep it. So what we're gonna do is adding a second grid. So we're gonna have a first grid for the tiles and a second grid for the blocking of the environment. That way we'll still have the grid to highlight the tiles and interact with everything, but we'll also have a second grid to just replace everything in the environment by gray blocks. I say gray, but it's going to have more colors than that because we're gonna have the different colors for the different tile types. That way we're gonna be able to identify them super quickly. So let's go do that. And the first thing we're gonna do is add that second grid. So it's gonna be in grid and it is in BP grid visual right here. And here on the left we have the child actor, which is our current grid, and now we want to have a second grid, so I'm going to duplicate it. And I added _tactical at the end of the name. And now what we're gonna do is go everywhere we were using the first actor and connect the second actor also. So I'm just going to right click on the first one and find references. And then we can go right here, where we are setting the grid mesh inst. And this is how I did it. So I'm doing the exact same thing right here. I'm getting the component. This time I'm using the second component we just created. I'm casting it to a grid mesh inst because it's still the same class. And then I'm setting it into a variable which I just created. So I created myself a new variable, which is the same as the previous one, but I added _tactical at the end of the name. And now we're gonna do the same thing, but for this variable instead. So I'm going to right click on it, find references, and go connect the new variable to every places that we were using that variable. And the first one after the set is this one right here. It's the get grid mesh inst, which is the one that is initialized the grid mesh inst. So we're gonna do the exact same thing, but for the other component. So here I just duplicated the code that we had right here, just over here, and we're gonna replace the variable with the new one, so _tactical. And for the mesh and material, we're actually going to use the 3D mesh and material because it's going to make more sense. So I'm going to connect the mesh right here and the mesh material right there. And we can now go to the next one, so this one right here, inside destroy grid visual. And it's as simple as the previous one, so we simply duplicate the code, paste it here, and replace the variable. So take the _tactical one instead of the normal one. And now we have the last two, which are in update tile visual, so we're gonna go here. And same thing once again, I just duplicated that bit of code and pasted right here, and now we can replace the variable like so. But here there's one other thing that I want to do differently, and it is to replace the isTileType workable. Instead of displaying only the workable tile, we want to display all of them. So what I'm going to do is just search for not equal right here, not equal enum, and replace it by a not equal none. So everything but the none types, we're going to display them like so. And I think that's it for the initial setup. It's not going to work perfectly, but I think we should be able to see, okay, yeah, we see something. Okay, let's press play. And now if I generate the grid based on the environment and then hide that environment, we can see that the shape remains perfect. The color is a little bit broken, so we're gonna go fix that real quick, but at least the shape is there. Good. And the colors are in the grid mesh inst. So let's open utilities and BP grid mesh inst right here. And here are the colors. But here the colors are set based on the states of the tile, but we don't want to do that. We want to base it on the tile type because we have different colors for the flying units, double cost, triple cost, and the obstacles. So what I'm gonna do is select my function and add a new input for the tile type. So the new input, I named it a tile type and it is of type eTileType. I placed it first just because I like it that way, and I also renamed the function for get color from state or type. And now what I did is just add a branch right here so we can decide if we want to use the tile type or the states. And what I'm gonna do is right click on the condition and promote to a variable. I renamed it isColor based on tile type. It's still a boolean and I changed the default value to make it false. We're gonna set this variable when we are initialize this blueprint. And now if it's true, we can simply return passing it a select node based on the tile type, and then we can choose some specific color for all the different tile types. In my case, I just have 3 shades of gray for the normal, triple cost, and double cost, and the obstacles are red, the flying units are purple. And now the last thing we have to do is to go set the value of this variable, and it is going to be in the initialized right here. And here what I'm actually going to do is to replace this right here, because we were setting a color but we were never using it. So I'm just going to delete all that and I'm going to replace the color variable for the new boolean. So here we go, the function receive a boolean now and it's named color based on tile type, and I'm passing it inside the set of my variable. Perfect. And now we just have to go set the right value when we are calling this function, which is in the grid visual, in the initialize function. We have our two functions right here. So we have the colors normal, the grid normal that is right here. We're going to keep it false. And for the new ones, we're going to make it true. So that way, only the second one is going to be based on the tile type. And now if we compile and go see how it looks, okay, it's not black anymore. Okay, generate, none. Okay, I don't have any other colors though. That's a bit weird. I think that's because of the material, so we're gonna have to go change the material also. So this is in the grid shape right here. We have the material for the grid and the grid flat, so I'm just going to open both. And if we compare both material, we can see that in the grid flat, which is the one that works, we have all that code that handle the colors, but on this side we just have the color node. So what I'm gonna do is simply copy all those nodes, paste them right here, and then connect them into the multiply like so. We don't need that color anymore because it's right there, so I can just delete that. And then we can save and it should work. Actually, never mind, it's all black still. Okay, let's go back in the grid machines to see why it happens. I'm gonna go in the color and actually, oh yeah, right here, we added a new variable, the tile type, but we are never setting it inside the function. So we're gonna have to go everywhere that we are calling this function and also pass it the tile type. So if I do a find reference on this function, I can see that it is called only here. So I have it right here and we have the tile type that is set to none by default. Okay, let's set it. We don't receive it from the beginning of the function, so I'm just going to drag it all the way back to the beginning just so it sets it, and then we can compile and access the variable like so. So compile and then get the type like so. And now we have to go pass the information to that function right here, and it is happening in the BP grid visual. So I'm gonna go right there, and it is inside the update tile visual right here. We are adding the instances. So we have the data type, we can simply pass it the type right here and right there. Bah, now if we compile, it should be better. Okay, good. Let's press play to see how it looks in game, I guess. Generate on the environment, and then I can hide my environment. Oh, great. So now I have all the red tiles that are my obstacles, the purple tiles for the flying units. These are triple cost, double cost, and everything seems to work perfectly. Great. But we still have a few things to fix for it to work perfectly. And the first one is the height of the red tiles, because right now they are all on the ground, so that's not really clear how high the obstacles are. So what I'm gonna do is stop and go select all my volumes that are for my obstacle in all my level. I'm going to select all of them, and then I'm going to check the use for tile height checkbox, like that, the same way we did for the flying units. And now if I press play, I can go see how it looks again. I'm gonna generate based on the environment and hide my environment. And now I can see that all my obstacles are at the right height. So I'm gonna continue and do that in all my level for all my obstacles. Here we go. So that's how it looks for my grid square. And then I'm gonna go in the hexagon, switch from my hexagon. Here we go. My obstacles are in the air at the right height. And then for the triangle, and here we go. That's how it looks. Perfect. Now the next step will be to scale those tiles, because right now the tiles right there, we can see that if they are in the air, they are not going all the way back to the ground. Same thing for my obstacles right here. So that's why we have holes here and there, and that's not really good because we don't really see what's happening. So what we're going to do is scale all those cubes that are in the air all the way back to the ground. So it's going to be all connected together. And we're going to do that inside the update tile visual function inside BP grid visual. So what I'm going to do is collapse all this inside the function because it's going to be a little bit different than the previous one. So we're going to keep a function for all that. But since I want it to be simple to create, I'm just going to drag from the data, connect it like so, add the reroute node in the empty space, and then select it with everything else. And now I can right click and collapse to function. And that's how it looks. So I renamed the function update tile visual, and I also renamed the input bit that was created automatically. I renamed it for data, the same way it was for that function. Now we can go inside the function to do the logic. And here the first step I did is to break the transform and then remake the transform just to separate the scale from everything else, because we're going to calculate the scale down here. And that's how I connected it. So the scale X and Y don't change. They are still the same. We just want to affect the scale Z. And this is the calculator I'm using. So here I'm getting the distance from the tile to the ground. So the position of the tile in Z gives us the distance from that tile all the way back to the ground. Then we are adding one tile size in Z, just so it's one tile higher than what it's supposed to be. That way the tile is not gonna stop flat with the ground. It's going to go a little bit lower, so it's going to be cleaner and nicer, I think. And then we can divide it by the height of one tile. That way it gives us exactly the scale that we need. So this is to convert the distance to a scale value. Okay, let's go see how it looks. Go back in entry. I'm gonna press play, generate my grid, hide the environment. Here we go. Okay, that's great. Now we can see that my cubes are super high up in the air right here because the obstacles are super tall. Same for here, here, and here. And here we can see all the steps that are all going back to the ground. Perfect. Oh, and also if you look at the tiles right here that are exactly at the same level as the ground, we can see that they are not flat with the ground. They are still a little bit thick, and that's why we were adding one size in thickness, so the tiles are not completely flat. They are still a little bit thick. So everything looks nice and pretty, but I actually know that it doesn't work because right now everything works, but it is only because my lower level in my grid is 0. There's nothing under the 0 in Z in my world. That's why it works right now. But if I stop and then let's say I move my ground a little bit down, let's say right there, and then I go back and press play again. And now if I generate my grid, we can immediately see that it doesn't work because right here all those tiles are completely broken because they are lower than the minimum height possible for my grid, because right now everything should be above 0 for it to work. So we're just going to modify a little something, that way it's going to support also the values that are lower than 0. And we're actually going to do a little bit something better than that. Instead of just supporting lower than 0 and giving it an arbitrary value, we're simply going to detect which tile in the grid is the lowest. So we're going to determine which one is the lowest, so that way, let's say if this one is the lowest tile in the whole grid, or maybe it's even obvious if I do that. So that's going to be the lowest tile right here. It's going to adapt the whole grid completely to that height level. And that's what we're going to do. So back in our function right here, I'm just going to create a new variable. It is going to be a float, and I named it grid lowest z. And I'm going to set the default value to something really big, so 999,999. And I included it in my calcul right here, so we're taking the height of the tile and then subtracting the lowest z. That way it gives us the real distance we need to calculate with. But now for this to work, we have to set that value. So we're going to do that just before calling all that code. So I'm just going to move this down a little bit and add a sequence right here. So we're going to calculate the lowest z at the top right here, and then we're going to apply it right there. And that's how I'm setting it. So every time we receive a new tile, we are checking is location z. Then we are comparing that tile z with the current lowest z. So we're checking if the new tile we just received is smaller than the lowest z. And if it's true, well, we are just going to set the lowest z using the new z that we just received. That way, this value will always be updated with the smallest tile on the grid. And now let's go see how it looks. So I'm going to compile, press play, and generate my grid. Okay, it seems perfect. Everything is now aligned with the lowest tile, which is all the way at the bottom right here. And now it's going to be the same thing. Let's say if I take the decrease tile, I'm going to do that. And then I'm going to decrease the height of this tile. So we can see that this tile goes all the way at the bottom. And then if we regenerate those tiles, we can see that they are now adapted to the height of that specific tile down there. We're not gonna make that they are all updated automatically because it's going to be a little bit too expensive, and I don't think that's worth it in this case because we're not really going to edit the grid that much while in the game, so I'm not going to add the functionality because it's going to cost too much performances for nothing in the end. But in the case that you really moved your tiles down a lot and then you wanted to regenerate the whole grid by yourself, you're going to be able to do that because we're gonna have a toggle to disable or enable the tactical grid, and it's going to regenerate the whole grid every time. So that's going to fix your problem if that's an issue for you. But before doing that, there's just a little bug that we have to fix, and it is that every time we are moving a tile down, so let's say I'm moving that one down, and then I refresh all the tiles and everything, and now they are based on that tile height. Let's say I want to regenerate my grid, so I'm going to regenerate my grid right now, so regenerate it like so. And then I can hide my environment. We can see that everything is now adapted to the previous tile height that we set. And it's not just one tile high the same way we wanted it to be. It's like super high for everything because it still thinks that the lowest tile is the one that I move down a lot. So we're just going to reset that variable every time we are regenerating the grid. That way it's not going to look like this, or even if I don't generate it based on the environment. Right now it's just a big, huge cube. So we're just going to reset that variable. And to do that, the first thing I'm going to do is start by setting this inside a function. That way we are going to simply call the same function every time. So I'm just going to right click right here and then collapse to function. I named the function setGridLowestZ, and I also named the variable simply z, and I've set a default value for that one. So the default value is 99999, the same default value that we used for the variable. And now we're gonna go call this function when we are regenerating the grid. So first in the destroy grid right here, we're gonna call it, so that way it's going to reset it every time we are destroying the grid. And the second place I want to call this function is in the initialize grid visual. Here it doesn't really matter where we are setting it, so I guess we can just set it at the end right here, like that. And now let's go see if it fixed the problem. So here I'm going to move one tile down a little bit, move it down, move it down, move it down, and then it updates everything else. And now if we regenerate the grid completely, I'm just going to do that first. Okay, it didn't work. Okay, here we go. And now we can see that my grid regenerated perfectly. Perfect. And now the next thing I want to fix is the height of the grid, because I don't know if you can see right here that the tiles are a little bit above the ground. They are not really exactly at the same level as the ground actually. It is based on the grid offset from ground, so if I increase it, it's going up, and if I lower it, it's going down, and actually it's going to work better if I write a bigger number, so let's say 50. 100, we can see that it's way higher than the ground, but we want that grid to be exactly aligned with the ground because that's supposed to replace the ground. So we're just going to make sure that it is not depending on the offset from the ground the same way we are doing for the other lines on the grid. And to do that, we're going to do that inside the set offset from ground function right here that we have in the grid visual. So let's go in there. And that's how we're going to do it. So instead of moving the whole actor up in the world, we're simply going to move up the grid mesh inst that we are interested in. So the first one right here. So we're simply going to move one component up a little bit based on the offset from ground. So it's going to replace that code. So I can delete it and replace it like so. And now if we go see how it looks, I'm going to press play. Here we go, now my grid is exactly at the same level as my ground, that's why it's flickering that much. And if I move my offset from ground, we can see that only the lines are moving up and down. Actually, it's going to be better if I write a big number, let's see, like that. So now we can see that the grid is way above the other grid, the tactical grid. So perfect, that's exactly what we want. And I think it's now time to fix that flickering. Right now it's happening because both the environment and the tactical grid are visible at the same time, but that should not be possible. In the end, the objective is to either have the environment or the tactical grid, not both. So we're just going to add another checkbox in the user interface to either enable or disable the tactical grid and the environment. So to do that, first I'm going to add a new function in the grid visual to be able to set that variable, so new function. I named the function setIsTactical and I'm passing it a boolean telling us if we want to set it tactical or not. And then using that boolean that we receive as input, we are setting a new variable that we have right there in the blueprint. And this variable is going to let us know if we are currently displaying the tactical grid or not. Then we're using that variable to set the visibility on the grid mesh inst component, that one right here. That way, if we don't want to display the tactical grid, it's going to be hidden and otherwise it's going to be visible. And then to control the visibility of everything else, we're going to use tags. So right here, I'm getting all the actor with the tag not tactical that we're going to go and add to all the objects that we want to hide when the tactical grid is visible. And then we're simply looping through all of them just to hide them if the tactical grid is visible. And now it's time to go apply the tag to all the actors that we want to hide. So I'm just going to copy it and go back in my level. So now with everything selected that I want to hide, so everything that is a static mesh that I want to hide when we are displaying the tactical grid, so all of that, I will go in the detail panel and search for tags right here. And now in the actor tags, not the tags, just the actor tags right here, I'm going to add a new element and paste my new tag, so the not tactical tag in there. That way, when we are calling the getAllActor with tags, it's going to give us all these actors and we are going to be able to hide them. So I'm going to also do that in all my other levels. And now that it's done, we just need one last thing, and it is a checkbox in the user interface to be able to call our function. So I'm just going to go in my debug menu, in my tabs, and open the tab grid. And here in my environment, right under my combo box, I just added a new checkbox, which I named is tactical, and I changed the text for tactical mode right here. Now I can select the checkbox and go implement the event, which is as simple as calling the setIsTactical function that we just created inside the grid visual and passing it the check state of the checkbox. And now one last thing, it is to go in the setDefaultValues just to set the default state of the checkbox. So right here, I'm gonna go all the way at the end right here. And we're doing it like that. So we are getting the isTactical state of the grid visual and then setting the check state of the checkbox. And now if we go back and play, we should be able to see the difference when we are toggling the tactical mode, like that. Okay, great. And it's even better if we generate the grid based on the environment. Okay, perfect, now that's good. We just have one little problem, and it is that the default state of the variable is not applied to the component, so we're just going to go apply it. I'm going to go back in the grid visual. And what we're going to do is simply go back at the end of the initialized grid visual right here at the end, and we are going to call this function with the state of the variable right here. And now if I press play, I should, okay, yeah, I start without a tactical grid, and then I can enable it and disable it perfectly. Good. And now, before ending this video, there's just one little optimization that we want to do, and it is to not always calculate the tactical grid. Because right now, even though the tactical grid is not visible, it's always calculating it. So every time there's a change with my grid, it also updates the tactical grid, but it's not visible. So it's calculating for no reason. So we're just going to deactivate that. And then once we activate the tactical grid, it's going to regenerate everything. So that way it's just going to generate it once when we activate it. And then once it's deactivated, it's not going to regenerate over and over and over every time there's a change with the grid. So here I'm back in my BP grid visual in the update tile visual tactical. I'm going to do a check before performing all that right here. I'm just going to add a branch right here to check if the tactical mode is enabled. So is tactical, is it enabled? True. Okay, do all that. And as I said, when the grid is not tactical, we are going to set a flag, setting it to true right here. It's a new variable that I created and I named need to regenerate tactical on next enable. That way the next time we are going to enable the tactical mode, it's going to regenerate the grid. And we're actually going to use the same exact boolean inside the set grid lowest z right here. That way, when we are enabling the tactical mode, we are gonna check if the grid lowest z was changed since the last time, and if it's true, well, it's going to regenerate the whole grid, adapting all the tiles. And now to use the variable, we're gonna do that in the set is tactical, because we want to do it every time we are enabling the tactical mode, so we're gonna do it at the end right here. So here, after setting the is tactical, if we just enabled it, so if it's true right here, and if we needed to regenerate it, so if both of them are true, we are going to start by setting it to false because we are going to regenerate it. So we're not going to need to regenerate it again because we're gonna do it. And that's how I'm regenerating it. So I'm simply going through all the grid tiles in the grid, and then I'm calling the update tile visual tactical. Only the tactical one, because the other one was already updated. So we're simply going to call that function for all the grid tiles if we needed to regenerate the grid. And I think that's it actually, so I'm gonna go back in the level, press play, okay, everything looks good, here we go. Now if I enable my tactical mode, it works perfectly, great. Now I can just update the tiles, so I'm going to update the height of the tiles and move tiles around and stuff like that. It's fine, it doesn't matter. It doesn't update the tactical grid yet, but when we are clicking on tactical mode, we can see that everything's updated and the tiles now have all the right height, everything everywhere is now at the right height because we regenerated it. Perfect! So everything seemed to work as expected, and I think that's gonna be it for today. So I'm gonna see you in the next one. Bye bye!